Imagine a camera so powerful that it can capture billions of galaxies, see the invisible, and even help discover a planet in the solar system. This camera exists, and now it has just revealed its first images. What you are seeing is the first image recorded by the largest digital camera ever built for astronomy. It is now installed at the Vera C. Rubin Observatory in Chile. This impressive image shows part of the Virgo Cluster, a group of galaxies about 55 million light-years from Earth, the closest to our own galactic group. The level of detail is astonishing. Stars with tones ranging from blue to red, nearby spiral galaxies with a bluish glow, and distant clusters in reddish tones. Altogether, this image contains more than 10 million galaxies and was created from nearly 100 photos taken in just 7 nights. No other telescope in the world can capture such a wide and deep image of the universe this quickly. And this is just the beginning. The Vera C. Rubin Observatory was built for something much bigger. With a 3,200 megapixel camera, the largest ever used on Earth or in space, it will scan the entire southern sky every 3 nights for the next 10 years. That means about 20 TB of data per night, creating what will be the most detailed movie of the universe ever made. In addition, Rubin will help identify asteroids, supernovae, the effects of dark matter, and phenomena we have never seen before. It is estimated that more than 37 billion stars and galaxies will be part of the final catalog, completely transforming our view of the cosmos. But what makes Rubin so special? For centuries, astronomers studied space through static images, as if they were photographs frozen in time. Rubin changes that completely. It was designed not to take isolated pictures, but to record a kind of continuous video of the sky. This allows us to track moving events, such as stellar explosions, asteroid collisions, or any change in the brightness of stars, something that previously went unnoticed. It is like a security camera in space, recording everything in real time. At the heart of this system is the LSST camera. It is about the size of a small car and weighs around 3,000 kilos. Its main lens is 8.4 meters in diameter, capturing an enormous amount of light. Its field of view covers an area of the sky 40 times larger than the full moon, all in a single exposure. And how does all of this work? Every night, Rubin photographs the sky. These images are compared with a reference image of the same region. The difference between the two reveals only what has changed, such as a new star or a moving object. This makes it possible to detect around 10 million changes in the sky every single night. Each exposure lasts 30 seconds, and in just 5 seconds, the 3-ton telescope is already pointing to another part of the sky. The cycle continues non-stop throughout the night, covering the visible southern sky every 3 nights. With this comes a flood of data, 20 TB per day. Over 10 years, that will exceed 60 petabytes, the equivalent of 500 times the data collected by the Hubble Space Telescope in 35 years. For comparison, Hubble collects about 8 TB per year, and the James Webb Space Telescope about 200. Rubin alone surpasses that in a single night. This massive amount of data represents a revolution in how we study the universe. Rubin will reveal objects and events that have always been hidden, faint galaxies, fast phenomena, and much more. The first image released is simply breathtaking. It covers a huge area of the sky, about 14 square degrees, which is equivalent to 70 times the size of the full moon in the sky. And it was built from more than 3 trillion pixels captured in just 7 nights. Let's take a closer look at the incredible details of this image. One of the highlights is the elliptical galaxy Messier 49, or M49, which appears with a soft yellowish glow. It is composed of older stars, giving it a reddish tone, indicating that the formation of new stars has already been greatly reduced there. Next to it, we find NGC 4535, a face-on spiral galaxy with bluish tones and well-defined arms. It is filled with young and bright stars, a true stellar nursery. Between these two giants, there is a wide variety of other galaxies, spirals, massive ellipticals, and even small dwarf galaxies. And in the background, like small red spots, we can see even more distant galaxies, some more than 1 billion light-years away from us. A little further on, we find one of the most impressive galaxies in the Virgo Cluster, Messier 61 or M61. It is a perfect spiral, seen face-on, similar to our Milky Way. Discovered nearly 250 years ago, M61 hosts a supermassive black hole at its center, with about 5 million times the mass of our Sun. But what stands out the most is its level of activity. It is undergoing intense star formation, which classifies it as a starburst galaxy. Its bright blue arms show the birth of millions of young and hot stars. And then comes one of the most exciting parts of the image, a triple galaxy collision. 3 galaxies merging into one in a true cosmic chaos. Their shapes are distorted by each other's gravity, creating tails, bridges, and arcs of matter. It is a visual spectacle and also a transformative process that can create new stars and even activate black holes. Just below, there are 2 spiral galaxies that seem to be dancing together, but in reality, they are separated by about 20 million light-years, a distance enough not to interact gravitationally. A reminder that, in space, not everything is what it seems. And right nearby, there is another subtle but fascinating detail, a cluster of distant galaxies seen as a group of red spots. These points are so far away that their light took billions of years to reach us. And even so, Rubin managed to capture them. Scattered throughout the image are also extremely bright objects with rays coming out of them. These are stars from our own galaxy. These rays are not part of the stars themselves, but are caused by the way light interacts with the telescope's supports. If you notice irregular edges in the image, it is not a processing error. These are areas that the telescope has not yet been able to fully capture, part of the work still in progress. In the upper left corner, you can see the region of the triple collision, one of the highlights of the image. But the most impressive thing is that most of the objects in this image have never been studied before. Many have not even been seen until now. Thanks to Rubin's depth and reach, we are discovering for the first time cosmic structures that have always been there, but until now were invisible to our eyes. Stars and galaxies were not the only incredible things revealed in Rubin's image. There is something else spread throughout, but difficult to notice at first glance. These colored lines crossing the image are asteroids. They show the movement of these bodies as they passed in front of the camera during the telescope's long exposures. Rubin, however, is smart enough to identify and remove them from the final image, ensuring a clean view of the deep universe. Even so, it still records them. In just 10 hours of observation, Rubin detected nearly 100 asteroids, many of them never seen before. For comparison, all the other telescopes in the world combined usually discover about 20,000 asteroids per year. Rubin is expected to multiply that number by 5 in just a few years, taking our knowledge about these small bodies of the solar system to a new level. Another spectacular image from Rubin shows a vibrant region full of star formation, the Lagoon and Trifid nebulae. The Lagoon Nebula appears as a bright pink cloud shaped like a bean. It is about 4,000 light-years away from us and is a massive stellar nursery. With binoculars or a small telescope, it is already possible to see it in the sky. Above it is the Trifid Nebula, even farther away at about 5,000 light-years. It is famous for its mix of colors and shapes, part emission, pink, part reflection, bluish, and divided by dust lanes that separate it into 3 distinct regions. That's where the name Trifid comes from. Within it, stars are being born right now, and the winds and radiation they emit are shaping the surrounding gas. Together, these 2 nebulae show us a fascinating portrait of the early stages of stellar life. The Vera C. Rubin Observatory was created to answer the deepest questions in astronomy and physics. It will operate on 4 major scientific fronts. Rubin will observe phenomena that appear and disappear rapidly, such as supernovae, gamma-ray bursts, and active black holes. It is estimated that it will detect around 100,000 supernovae per year, some billions of light-years away. These supernovae are essential for measuring distances in the universe and understanding its expansion. It was through them that scientists discovered that the universe is accelerating, which led to the theory of dark energy. In addition, Rubin can capture the exact moment when a star explodes, helping us understand this process in more detail than ever before. The observatory is named after Vera Rubin, the scientist who, in the 1970s, showed the world the first concrete evidence of dark matter. By studying the rotation of galaxies, she realized that stars were moving too fast for visible matter alone to hold them together. Her discovery revolutionized physics, and today, Rubin continues her legacy by seeking to map dark matter and dark energy, which together make up about 95% of everything in the universe. It will do this through a phenomenon called weak gravitational lensing, where the light from galaxies is slightly distorted by the gravity of the matter it encounters along the way. By measuring these distortions, Rubin will create a large-scale map of the distribution of dark matter. Rubin will also conduct the most complete survey of the bodies in our solar system. Today we know about 1 million asteroids, most of them in the belt between Mars and Jupiter. But Rubin may discover millions more, including near-Earth asteroids that could pose risks in the future. And it doesn't stop there. It will explore the Kuiper Belt, where the most distant and icy objects in the solar system are located. Today we know only a few thousand of these bodies, but Rubin is expected to reveal tens of thousands of new frozen worlds. It may even help solve the mystery of Planet 9, a supposed giant hidden in the outer reaches of the solar system, suggested by the unusual orbits of some of these objects. Even if Rubin does not see it directly, it may find clues to its existence. Finally, Rubin will help us understand the origin of our galaxy, the Milky Way. It will map billions of stars, including those in the outer regions of the galaxy, revealing traces left by ancient collisions with smaller galaxies. These traces, called stellar streams, act like cosmic fossils, showing how the galaxy formed over billions of years. It will complement the incredible data from the European Gaia mission, which created the most precise 3D map of the Milky Way to date. Rubin will expand this work, going even farther and deeper into space. Rubin is still at the beginning of its mission, but it is already changing everything we know about the universe. Never-before-seen galaxies, unknown asteroids, clues about the birth of stars, and even answers to the biggest mysteries of modern physics are being revealed. If you enjoyed the video, don't forget to leave your like and subscribe to the channel. Thanks, and see you next time.